Okay, so the purpose of this video is to go over the review for dilating and reflecting exponential graphs. So I'll go through one of the typical examples here with you to make sure you understand. So I'm doing the one in the middle of the paper here. Y equals 2 parentheses 3 to the x power. Okay, so kind of combines two topics we've learned about: exponential graphs and transformations that we learned about earlier in the year. Okay, so the first thing you want to do is understand what is your basic exponential function. In this case, we kind of think of it as a parent function for this type. So it would be 3 to the x, so whatever is being raised to the power of x. So the first resource we can use to help us with that is this basic exponential functions page. We've got y equals 3 to the x. We've got some of the most important points along the curve, and then we've got a rough sketch of what the curve looks like on that sheet as well. Okay, so we're going to be transforming this function. So what I typically like you to do is to take some of the nice integer points and write them down on the paper you're working on. So we're looking at kind of our basic function y equals 3 to the x. Our basic xy points are 0, 1, 1, 3, 2, 9. There's obviously more in both directions, but those are the key ones that we know will fit on most graphs. Okay, and we're performing this transformation where we're doubling that. Okay, so this 2 is outside away from our value of x, so that's indication it's going to be a dilation in the vertical direction. So the other document that's helpful that we had from earlier in the year is this transformations document. We said this would be helpful all year long, and that's still carrying true here. So the form of the transformation that we're looking at here is c times my original function. Okay, so c times 3 to the x. So this middle area tells us what happens to each one of the points. So your original point a comma b is transformed into a, where so your x value stays the same and your y values are just multiplied by whatever this value of c is. Okay, and we know verbally that this is going to stretch your graph in the vertical direction. Okay, so mathematically, what I'm going to do to each point, you can see here, leave my x's alone, and I'm going to multiply my y values in these three original points by 2. If I need to add any more afterwards where I see that it would be helpful, I'll do that then. Okay, but I'm just going to do each of these transformations. So it's going to be 0, 2, 1, 6, and 2, 18. Okay, and most likely I won't need too many more points. Maybe some if I have a big gap between where my last point is and where we go off the grid. Okay, so I'll just simply plot those here. So 0, 2, 1, 6, 2, 18. Okay, so you can see in this direction here we're going way off the grid vertically, so you can make it almost vertical as we go off up here. Just want to make sure the next value here would be much larger than 18. So make sure I don't see x equals 6 or x equals 3. I'm sorry, being touched here on the graph. That would get points off. But I should see 3 nice dots at the grid marks here at those 3 points. Now there is a bit of a gap between 0, 2 and where your graph is going to be flattening out. So if you wish to, you can try, a point to the left over here. So in our basic pattern, we have negative 1, 1/3. That, when you double it, becomes negative 1, 2/3. Okay, not super helpful, but we can kind of see where that would be. So negative 1, it's not quite up to 1. Okay, so just something in there. So sometimes picking up that extra point or 2 will help. In this case, it didn't help too much. Okay, but so we know from there it will flatten out and almost be a horizontal line as we go off the grid here. Okay, so that's your basic exponential function, and then the transformation. Okay, so you want to use these two documents all the way throughout. Identify your basic function first, and take the key points, understand what the graph looks like in general, and then identify your transformation on this. Again, the focus here are your dilations and reflections on this sheet. So remember, reflections are indicated by negative signs. So if there's a negative sign out in front away from the x, that's going to be a reflection over the x-axis, so vertical, flip upside down. Okay, if there's a negative, up with the x, it's going to be a flip over the y-axis, and that's horizontal there. Okay, and then all of these ones with the c's, so whether it's inside with the x or outside away from the x, those are the other ones we'll be focused on here. Okay, so vertical and horizontal stretches and compressions, or stretches and shrinks if you want to call them. Just pay attention to what this tells us to do with the math, and check your graph at the end to see if the picture looks like it did what it was supposed to. Okay, so thanks for watching, and good luck on the rest of these problems.